Hello, welcome back to another capacity chemistry video. This one is all about elimination in the haloalkanes topic in year 1 of AQA A-level chemistry. Now the first question is, what is elimination? Now, elimination according to the dictionary is the complete destruction of something or the removal of something. And in this case, we start off with a molecule, we'll call it A. It turns into B, and a small molecule is removed. In the haloalkanes topic, we'll start off with a haloalkane. It will turn into an alkene, and the small molecule that gets removed is water. Now for this, there is a mechanism, and you do need to know the mechanism. Here it comes. Now, some of you are thinking that this looks familiar. You've seen something like this before. Here's a haloalkane, here's a hydroxide ion, and you're thinking nucleophilic substitution. But no, this time it's different. This time, the OH minus is going to act as a base. What does that mean? It's going to be a proton acceptor. And why is it going to be a proton acceptor this time? It's because the conditions are different. Now for this one, the conditions are, it's got to be ethanolic, or you've got to have concentrated hydroxide, so that's either concentrated potassium hydroxide or concentrated sodium hydroxide, and we're going to use a technique called reflux. Now with this one, I'm always telling my students to look for the Harry Potter lightning bolt. Now I'm going to show that to you. Here it is, the Harry Potter lightning bolt. There it is. It looks a little bit like that, which if I draw in eyes, a nose and a smiley face, give him some glasses and a little bit of hair, just like Harry Potter, straight out of the films. Now why is that important? Who cares about Harry Potter? You're right, no one cares about Harry Potter, let's get rid of him. But what you need to look out for is for this shape, or for a U shape, in the haloalkane for elimination to occur. Now, as a base, this hydroxide is going to try and take a proton. It's going to try and take this proton or this proton. So the carbon with a halogen has to be next to a carbon with at least one hydrogen. Now I'm saying look for the lightning bolt. Why am I saying look for the lightning bolt? Because I'm going to draw a curly arrow from the middle of this lone pair of electrons to next to that hydrogen. When we draw arrows next to a hydrogen, that means that it's going to form a bond with it. And I'm going to draw an arrow from this middle of this bond to that one. And what that means is those electrons are being transferred into those. And what happens is we've got a double bond there. If we put in a double bond there, this carbon will then have 5 bonds, which can't happen. Carbon can only have 4. So what's going to happen is these electrons are going to go from the middle of that bond to that bromine, and it's going to turn it into a bromide. Now our product, let's draw it down here. That is now called prop-1ene, or propene. You don't need the 1. We've also got water being formed from that hydroxide, taking that hydrogen. And we've also got a bromide ion. And that's the mechanism. Now the key bits. Key bits are this reaction is ethanolic. You're using a hydroxide. That can be either potassium hydroxide or sodium hydroxide. And that needs to be concentrated. So I'm going to write that next to it. Conc hydroxide. And you need to look out for this thing, the Harry Potter lightning bolt, when you're trying to do questions on elimination. Hope that makes sense. If you have any questions or comments, please leave them below. If you liked it, please like and subscribe. Thanks for watching. See you next time.